A buck regulator is a DC-DC converter which converts a higher voltage potential to a lower voltage potential. It uses a switching element to ensure steady DC output of required voltage. I am Reshma, and today we will discuss the operation of a buck regulator. In today's topic, we will talk about buck regulator operation when the switch is turned off and when the switch is turned off. Buck regulator operation when a duty cycle is applied to the switch. The output of the buck regulator is steady DC. As we discussed earlier, the output voltage is lesser when compared to the input voltage. This is achieved by controlling the duty cycle of the switching element. The switching element can be a transistor, MOSFET, or an IGBT. When the switch is turned on, the diode is reverse biased and the energy from the input is stored in the inductor and supplied to the load. When the switch is turned off, the energy stored in the inductor is supplied to the output. It can be noticed that switching regulators are more efficient as the voltage across the switch is 0 volt when it is turned on. The user can control the duty cycle and regulate the output. However, when compared with linear regulators, they are more complicated in construction. Let us first turn on the switch. As the switch is turned on, the switch impedance is almost equal to 0 ohms. Hence, the voltage drop across the switch is also 0 volt. Now the diode and the input voltage are in parallel. As a result of this, the entire input voltage appears across the diode. As the anode of the diode is connected to the negative terminal of the input and cathode of the diode is connected to the positive terminal of the input, the diode is reverse biased. It acts like an open switch and it does not conduct. However, the inductor is connected across the positive terminal of the input voltage and the output terminal. As there is a voltage difference across the inductor current starts to rise. Here, the source provides the current to the inductor and to the load. Let us now turn the switch off. The resistance across the switch is high and it acts like an open switch. Now, the diode and the input voltage are no longer connected. The input voltage no longer supplies current to the inductor and the load. We know that the inductor always tries to maintain the same direction of current flow in it. In the circuit too, the inductor tries to maintain the flow of current in the same direction as it was flowing just before turning off the switch. To achieve this, the voltage polarity across the inductor reverses. This causes the diode to be in forward biased mode. Hence, the voltage drop across it is forward voltage drop. The inductor current now flows through the load and the diode. Now the inductor supplies current to the output load. As a result of this, its magnitude starts reducing, or we can say that current in the inductor starts reducing. However, it should be noted that the direction of the current has not reversed. Let us keep the switch on for time t on and keep the switch off for a duration of t off. Let us keep on repeating this pattern of turn on and turn off. Here, total time is given as t total, that is equal to t on plus t off. The frequency at which the switch is turned on and off is given as f. F is equal to 1 by t total. The ratio of the duration for which the switch is turned on to the total time of operation of the switch is called as duty cycle D. D is equal to T on divided by T on plus T off. It can also be written as T on by T total. Thus, T on is equal to D into T total. With this equation, we can calculate T off duration. Let us substitute T total as T on plus T off in this equation. On solving it, we get T off as 1 minus T into T total. In this video, we saw how a buck regulator operates when the switch is turned on and when the switch is turned off. We also saw the duty cycle definitions. In our subsequent videos, we will see how to regulate the buck regulator. Until then, let's keep exploring and learning. Thank you.